Hello and welcome to the Advent of Code 2021, day 14. Today we are giving a starting polymer, which is a sequence of uppercase letters of size 4 in this case, but there is no specific size, and a list of rules. Every rule starts with 2 letters and ends with another one, so associates a couple of letters to a single one. What we have to do is essentially to expand the polymer according to these rules. So for example, here there is an NN. We find the rule that associates with NN, this one, and then goes to C. So the polymer will become NCN in this point. Then we do the same for N and C. We find the rule, NC, where is it? Here. NC becomes B, so instead of having NC, we'll have NBC. Essentially, every rule is putting something inside the polymer between 2 letters. After we do, we end up with a longer polymer with more letters inside. Every 2 letters there is an extra letter added by this step. And we can iterate over the next step. So we again compare the polymer in which we add the letter with the rules, and we add new letters. At every step we add more and more letters. We insert every time into a pair. Here you can see an example. And the problem is asking us to expand the polymer for 10 steps and calculate what is the most and least common element, and the difference between the two counts is the solution for the part 1. So I start with the copy of the sample problem so that I can try my solution on a known input, see the result, and then try it on the real input. So I already copied on the day14.txt the sample input, the one that we have in this in the problem solution, and now we have to implement. So first, let's parse the file. So I iterate over the lines, and I have 2 cases. I have one line that contains the polymer, and other lines that contain the rule. So let's start with the polymer. So I create a variable called polymer, initially empty. I can also create it in the for, but I prefer to have it a single time. And here I say that if the line doesn't contain this symbol, which is the one that defines the expansion rules. Let's start with the reactions. So the reactions will be a dictionary, because it goes from a couple of letters to the one to insert inside. So I say that if this thing is in the line, so if the line contains this arrow sign, which means it's a reaction, then I say, how do I call it, couple, then nothing, then the result, the insertion, let's call it, is equal to line dot strip, because I want to ignore the new line at the end and every space, dot partition, and what am I partitioning on the arrow sign, plus the 2 spaces that are on the right and left. Notice that the 2 spaces are not removed by strip, because they're not at the end of the string, so they're kept. Only the ones at the end of the beginning of the string. And now that I have the couple, which is the first part of the string, and the insertion, which is the last part after this arrow sign, this underscore is just to ignore the second value returned by partition, which is the separator itself. We don't care about it. I add it to the reactions. So reactions of couple is equal to insertion. Then I say that, okay, if this line doesn't contain this arrow sign, could be an empty line like line 2 that I ignore, or has something. So I say that the length of line is greater than 1, so it's greater than just the uline character. And then the polymer is equal to line dot strip again. I hate white spaces, so just remove them every time I can, so that I have a proper input. Now, to be sure, let's print the polymer and also print the reaction, so that I can see that my problem is actually working. So at least the parsing is working. Okay. So the polymer is NNCB, which is correct. is this one. And reactions also seems fine. Okay, the none is because it's trying to invoke part 1 and part 2 that are, of course, not defined yet. I still have to solve the problem. Okay, so let's start by creating a function that calculates a single step. So I pass to part 1 the polymer and the reactions. And part 1 will go for 10 steps, because the problem says that we want to simulate 10 steps. So I say that for in range 11, because you know that range, actually we don't care, 1, 11. I want to count like a human, so I start from 1. So range 1, 11 will give me the number between 1 and 10. I want to extend the polymer, so I say that part 1, receiving the polymer reactions, we calculate a new polymer. So polymer is equal to reaction step, let's call it. It's a function that we're going to create that will receive the original polymer and the reactions. And then we print the step. So let's call it IDX. I will print this step and the polymer. So I simply want to print what is happening at every step. Now I have to define reaction step, which is where the actual reaction happens. So reaction step, we receive the polymer and the reactions. And what it has to do is to go through all the couples, so all the letters that are one after the other in the original template. How do we do that? Well, it's simple. We let's call it A and B. We iterate over polymer. We iterate over the zip of polymer and polymer, ignoring the first element. So this is a simple and very common way in Python to iterate over consecutive elements. Another thing you can do is just to have a for on a range that goes from 0 to the length of polymer, and every time take the element at that position and the position plus 1. This simply takes the polymer, shifts it by 1, and with zip it gives me a tuple that contains an element and the next one in the polymer. So now I have A and B that are two consecutive letters in the polymer, and I want to get the reaction between them. So I get the insertion, which is equal to what we have in reactions corresponding to these two letters. So reactions, in which position? At the position A plus B. A and B are strings. A plus B means just a concatenation. So I'm getting, for example, N here and C here, and concatenate them to get NC. And then in this dictionary I will find the key NC, for example, here, and C will give me B. So insertion is the new letter that I have to insert between A and B. What I do with this, I create a list of insertions. Initially empty. Actually, this is a string, so I can treat it as a list of a string, it doesn't matter. Insertions dot append insertion. Can we simplify this code a bit? Yes, because first of all, this variable is created only to be used here, so we can just copy paste this thing into here and have a single line. And then you can notice that this is just a list comprehension. Insertion is completely defined by this, so also this is a string, and here I'm doing append, so it makes no sense. Let's say the insertion is just a list that contains this thing for A and B in polymer, blah blah. So I'm simply transforming this stuff into a list comprehension, because there is no reason to have an explicit for. It's very simple. I do it only because it's a very simple operation. If it was more complex, I would prefer a for, just because it's more readable. And why do stuff in a complex way when you can do it in a simpler way? Okay, so we found the insertions. which is essentially the list of all the letters that we have to put inside this polymer. Now we have to interpolate, so essentially to get one letter from the original, one letter from the insertion, one letter from the original, letter from the insertion, until we find the complete list of letters. How we do? Again, the same trick. In fact, we can just copy paste brutally this thing. Here we interpolate the polymer and insertions. So let's call it O for original and I for insertion, just for clarity. And let's call it result. The result will be a string. So I simply say, okay, result plus equal O plus I. Notice that polymer insertion will have a different length. Why? Because insertions are put in the middle of the polymer. So if the polymer has 4 letters, insertion would be 3. I mean, look at the fingers of your hand. If you have 5 fingers, there are 4 spaces between the fingers. So there is always 1 letter less in the insertion than polymer. So this zip will actually stop and leave out a single letter from the polymer, because the polymer is 1 longer. For example, NNCB will have 3 letters that are between N and N, between N and C, between C and B, so 3 letters, but there are 4 letters in NNCB. And that's just a result of the problem. So we have to add the last letter, the B in this case, like this, result plus equal the last letter of polymer. And we return the result. We can also just return the result plus this thing and remove this line. It's the same. Okay, so now we can, in theory, run part 1 and see what happens. If we run the problem, we can see how the polymer evolves. Okay, so it becomes very large very soon, which is expected because at every step we double the size of the polymer. So in 10 steps it will reach 1024 multiplied by the size, the original size. And also I have to print the original polymer. Well, we know it because it's already in progress. So step 1 will be NCN BCHB. NCN BCHB. Step 2 will be this thing. I already don't want to compare, but it seems correct. NB blah blah CB. NB blah blah CB. Okay, it seems correct. What is the problem asking? It says that okay, step 1 it seems correct, so we are matching correctly the steps and the length. What is the problem asking? Is asking us what do you get if you take the quantity of the most common element and subtract the quantity of the least common element. This is trivial because here, after the whole thing is processed, we can just create a counter. So I use my favorite Python module, which is collections. From collections import counter. I wrote form. Okay, counter is a very nice module because it gives me directly count. So I say C equal counter of polymer. This will count how many letters are there. In fact, I can also print it just to be sure. So I run again, see what happens. The counter is telling me, okay, B appears this many times, N appears this many times. And here it says, okay, B appears 1749 times, which is what we get. And H appears 161 times, which is correct. The problem is asking us to get the most common and the least common. The most common actually has a function already in the counter. Most common, which gives me a list. Okay, so most common as a parameter, which most common essentially you can see from the documentation gives me a list, a sorted list of the elements that are in order of frequency. So if I can ask it, for example, the 3 most common elements, but if I pass none, I get all the elements, which is exactly what I want. So essentially I get a ranking of the frequency. So let's call it frequency ranking equal this thing. I don't like to have this C variable that is basically never used, so I simply create here the counter just for the sake of this. So I create a counter and get the count the most common, and now I can just take the first and last element, because they will be the most and least common. Let's also print just to give an idea. I can ignore this print. Freq ranking. I print them, and here it is. So I get this list that is telling me, okay, B appears this many times, H appears this many times. The problem is asking us to get the difference between this and this value, which is just the difference between the first element of Freq ranking, which is this tuple, B1749, but I get also the number. I don't care about the tuple, but only about the value, minus the same thing, but at the last position, so -1. This is the solution, 1588, which is here the actual solution. So I can comment out this part. I can also comment out, what was it, there was another print somewhere. Yes, I don't care anymore. I know that the parsing works. And this is the solution. So now I try it with my real input. If it opens. No, it's not working. Okay, it's working. It's quite longer, which is expected. I run it. 2745. So this will be the solution. 2745. Yes, see you for part 2. Thank you for watching. Bye.